Hello. So, um, we're looking at number 4 here, and let's go ahead and dive right in. So, a dart with a mass of m is fired into a wooden block of mass m. So, little m for the dart, capital M for the block, suspended at the end of a light string of length L, capital L. After the dart strikes the block, it becomes embedded in the block. The block swings to the right, and the string makes an angle theta from the vertical. Determine the velocity of the block after the collision. So this is another one, just like some of the other ones we've seen, where we're going to use something else to find out the velocity, and then after the collision, and then we'll use momentum to find the velocity before the collision. Okay. So in this problem, just imagine we have a pendulum. We have some sort of initial velocity, right? That's what we're looking for. And then it swings up to some new position, okay? And we want to know what that new, what this velocity here is at the bottom, okay? Now remember, anytime I'm looking for velocity and it's not a collision, what would be the method I would use? Yes, hopefully you know that should be an energy question, okay? Now, what kind of energy do we start with? Yeah, just my kinetic energy. And then what kind of energy do we end with? Just potential energy from gravity. Okay? So it doesn't look too bad. Actually, the trickiest part of this is actually finding out the height. So we're really looking for this height here. Okay? And so the way we need to find that is we need to find out this length right here, okay? We know that this is L and we have this is theta, okay? So that will be L cosine theta, right? So that will be that yellow part right there, okay? So that's be our yellow part. But we actually want to find this height right here, okay? Now we know that the whole length is L, okay? So to find that blue part, okay, that height, right, that's the same as this height right here, that is going to be equal to the full L, right, that's my full length, minus L cosine theta, okay? So that's an important step. It's a bit of geometry there to figure it out, but you kind of have to be able to do that before you can solve the energy question, okay? Let me go ahead and label this as A. So I have KE equals PEG, so let's go ahead and plug in 1/2 mv squared equals 1/2 mv squared. The m's here would be actually m, lowercase m plus uppercase m, but since it's the same mass for both, those just cancel out. I'm sorry, I wrote the wrong equation here, so let me go ahead and erase that, okay? So this is just mgh, right? But the m's still cancel out because it's the same mass in both sides, okay? And remember, like I said earlier, it is m plus m, but since it's the same, they just cancel. Okay, I'm solving for v, so then I get 2gh root equals v, but I can't leave this h in my question. I need to go ahead and plug in what I found over there. So v equals 2gl. So what I'm actually doing here is I'm factoring out the l. So that's just L1 minus cosine theta. Okay. So L1 minus cosine theta, and then I need to take the square root of this whole thing, okay? And so that will be my answer right there, okay? Now let's go ahead and look at, sorry about that. Let's go ahead and look at part B, okay? So let's go ahead and look at part B. So it says, determine the velocity of the dart before the collision. So for this, we're just going to use momentum. So the sum of the momentum at the beginning is equal to the sum of the momentum at the end. Now that I know sort of that velocity after the collision, I can now find out the velocity before the collision. So I have mvi. So this vi here is what I'm looking for. And then here I'm going to have m plus capital M, right? This is where they're sticking together, times vf. Now, this VF here is going to be the initial, or that VF at the part A. Okay, that's kind of what we already solved for. Okay, so I'll have VI equals M plus M over lowercase m root 2gl1 minus cosine theta. Okay? And so that gives me the initial velocity before the collision. And so setups like these are sort of common if what we're trying to do is solve for the initial velocity of this dart. Okay? It's actually a clever way of saying, okay, maybe I can't measure this directly, but if I control these masses and I have the right things, I can just measure this angle, right? I can see exactly how high up it goes and then use that to find my velocity. So this is a common setup you might see in a question. Okay, let's go ahead and look at part C. Okay, so determine the ratio of kinetic energy to initial kinetic energy to the final kinetic energy. Okay, so this would be KE of the dart, because that would be my initial, to KE of the system. So that's with the block, the dart and the block. Okay. And so this will just be the KE of the dart over KE of the system. Okay, so let's go ahead and plug in. And so we get 1/2 little m v squared over 1/2 capital M plus m v squared. Okay? And so this velocity here is going to be, so this velocity here, whoops, let me go ahead and delete that. This velocity here is going to be this velocity here. Okay, so that's the velocity of the dart, right? That's velocity before the collision. Whereas this velocity here, this is the velocity after the collision. So that velocity is going to actually be this one. Okay. So let's go ahead and plug in. So I'll have sorry about that. 1/2 m, and then my v is going to be m plus m over m, and this is squared, and then I'll have 2gl1 minus cosine theta. Okay, and that part was square rooted, so when I square the square root, it goes away, and this is going to be divided by 1/2 m plus m. Okay, and then I'm going to go ahead and find this one here. So my v is going to be very similar. So it's going to be 2gl1 minus cosine theta. Okay, and so when this was before, it was square rooted, but then I square it, so it goes away. So you notice that this part goes away right away. So that's pretty easy. The 1/2 is also going to go away. Okay, and so then this will be equal to m divided by m squared, right, because this m squared is coming from this, and then times m plus capital M squared divided by m plus capital M. Okay, so this one will cancel out with this one will cancel out with that, and we will be left with just m plus capital M over m. Okay, and so that gives us the answer for that one. Okay, and so that's just the ratio of kinetic energies. Now let's go ahead and look at part D. Okay, so if I scroll up, it says determine the tension in the string when the block returns to the equilibrium point. Okay, so now I need to actually find out this tension in the string, right? So if I want to find out a tension, that's a force, so I need to be looking at forces. Okay, so I have mg down, I have T up, okay? And so I'd set up my F net, so F net equals what? Well, the question is, what kind of motion is this, right? It's a parabola, it's going in a circle, so what kind of motion is it? Centripetal motion, right? So that means my acceleration must be up. Okay, so I have T minus mg. Remember, I always want to set the direction of acceleration as the positive direction. Okay, so T will be positive. And then instead of using ma for F net, I should use what? Yeah, mv squared over r equals T minus mg. Okay? Now remember, our m here is actually m plus m, because it's the total mass of, both the dart and the block. So my r is going to be what number? right? The r is the radius, which is L, okay? So let's go ahead, we'll change this to L, we'll have m plus m. And then my v is actually going to be the same velocity right after the collision. So that's that root 2gl 1 minus cosine theta, okay? So this, and then when I square that, it will just be 2gl 1 minus cosine theta, okay? All over L equals T minus mg. Now remember, as I just forgot, my m is equal to m plus mg. Okay? Now, you'll notice that these L's actually cancel out, right? Okay? And then I'm going to go ahead and subtract this. Actually, before I subtract this, I'm going to multiply out a little bit. So I have m plus capital M, and then I'm going to multiply this 2g out. So it'll be 2g minus 2g cosine theta, okay? Equals T minus m plus mg. Now I need to add that m plus m to the other side, okay? So I have m plus m, 2g minus 2g cosine theta, plus m plus mg equals t, okay? And so now I'm going to go ahead and factor out this, and so this g will end up inside these parentheses. So I have m plus m, 2g minus 2g cosine theta, plus g equals t, okay? So this will just give me, I'm going to go ahead and factor out my g since I have that in every single term. So I have m plus capital M g, and then it will be, this will be a 1 plus 2, so it'll be 3 minus 2 cosine theta equals t. And so that is my final, whoops, that is my final answer, okay? So this was part D, okay? Once again, if you have a particular question that you needed to get answered, make sure you send me an email. I'd be happy to answer that, okay? Thanks.